pleasant greetings to all. In this video, I am going to explain time response analysis. Before we see the time response analysis, first of all we should know what are the standard signals available. The first one is step input, second ramp input, third parabolic input, and fourth one is impulse input. First of all, we are going to see step input. What is step signal or step input? A step signal is a signal whose value changes from 0 level to another level of magnitude. Mathematically, a step signal may be represented as R of t is equal to A when t greater than or equal to 0, 0 when t is less than 0. Now we are going to see the graphical representation of the standard step signal. The value changes from 0 to another value, that is A. So input R of t, that is equal to A when t is greater than or equal to 0. And when t is less than 0, is there any step signal? No. So R of t equal to 0. Next we are going to see how to find out the Laplace transformation of A. Here, what is the Laplace transformation of e power at? L of e power at equal to 1 by s minus a. Here, the constant only given, so I have to multiply the constant with e power 0t. If we multiply the constant with e power 0t, there is no change of value. So a into, what about the Laplace transformation of e power 0t, 1 divided by s minus 0. That is equal to a by s. So R of s is equal to a by s. Next I am going to explain the ramp input. Ramp input is a signal which starts from 0 level and increases linearly with respect to time. Mathematically, a ramp signal can be expressed as R of t is equal to at when t is greater than or equal to 0, R of t is equal to 0 when t is less than 0. Next, find out the Laplace transformation of at or Laplace transformation of R of t. What is the Laplace transformation of t power n? That is equal to n factorial divided by s power n plus 1. Here the value t is given, so a is a constant, so in a into L of t. So that is equal to a into n factorial means t power 1, so 1 factorial divided by s power 1 plus 1. What is the answer? A divided by s square. So this is the Laplace transformation of at. Next we are going to see the graphical representation. See, R of t and t both are directly proportional. So how to write the input R of t that is directly proportional to t? Whenever t is increased, R of t is also increased in a linear manner. So R of t is directly proportional to t. Have to add the constant of proportionality here, that is equal to a into t. So this is the equation for the ramp signal. So that is t greater than or equal to 0. But what about t less than 0? The value equal to 0. Next I am going to explain the third signal, that is a parabolic input. A parabolic input is a signal which is proportional to the square of the time represents the constant acceleration. Mathematically, the parabolic signal can be expressed as R of t is equal to at square when t is greater than or equal to 0 and 0 when t is less than 0. Next I am going to find out the Laplace transformation of R of t. So R of t is at square. Already have given the formula. So 2 factorial divided by s power 2 plus 1. 2 factorial means what? 2 into 1. So a into 2 into 1 divided by s cube. The answer is 2a divided by s cube. So this is the Laplace transformation of parabolic signal. Next we are going to see the graphical representation of the parabolic signal. See, in the parabolic signal, r of t, that is directly proportional to t square or acceleration. So r of t equal to a t square. So this is also applicable when t is greater than or equal to 0. What about t less than 0? The value equal to 0. Next I am going to explain the impulse input. An impulse input is a signal which is having 0 value everywhere except t is equal to 0. The function is generally called delta function. So see, del of t, that is equal to 0 when t not equal to 0, and a when t is equal to 0. It is having the value at t is equal to 0 only. So L of del of t is equal to 1, R of s is equal to 1. So this is the graphical representation of the impulse signal. See, in the impulse signal, a for a small value only, t is equal to 0. That is t tends to 0 or t is equal to 0, we are having the value a. All other value we get 0 only. So this is the impulse signal. So these are the standard signals available in the control system. Okay, these signals which are used to find out the performance of the system. Next I am going to explain order and type of the system. What is the order of the system? Order of the system is defined as the highest power of s in the denominator polynomial of the transfer function. And next I am going to explain what is the type of the system. The type of the system is defined as the power of separate s in the denominator polynomial of the transfer function or pole at the origin, that is known as type of the system. Pole at the origin. So that is known as type of the system. Okay, next I am going to explain this using some problems. The first one, identify the type and order of the following system with open loop transfer function. See the problem number 1, g of s into h of s equal to k into 1 plus st1 divided by s into 1 plus st2. See, what is the order of the system? The highest power in the denominator, that is known as order. So s into s, that is s square, order equal to 2. And what is type of the system? The power of separate s or the pole at the origin is known as type. Here the power of separate s is 1, so type equal to 1. Next, see the second problem, 10 into s plus 5 divided by s plus 6. Here, what is the type of the system? S power 0. So type equal to 0. And what is the order of the system? Order is equal to 1. And next see the problem number 3. 15 into 1 plus 5s into divided by s cube into 1 plus 6s. What is the type of the system? The power of separate s or pole at the origin. Multiply this s cube with s, we get s power 4. So order of the system equal to 4. And next we are going to see the problem 4. G of s into h of s equal to 100 into s plus 5 square divided by s cube into 1 plus 7s. What is the type of the system? Type is equal to 3. And what is the order of the system? Order equal to 4. Next I am going to explain the time response of the first order system. Let us consider the first order system shown in figure. So first order system means order equal to 1. See in the system 1 by Ts. Here S is the T is the time constant and S is the order of the system, that is equal to 1. Okay, here first of all I am going to apply the block diagram reduction technique. In the block diagram reduction, how to reduce the negative feedback loop. Here this is a negative feedback loop because output is connected to the negative terminal of the error detector. So the negative feedback loop. So what is the formula? C of S divided by R of S, that is the transfer function given, that is G of S divided by 1 plus G of S into H of S. What is the value of G of S? 1 by Ts. And here this is a unity feedback system. So H of S is equal to 1. Okay, next I am going to explain how to find out the transfer function. See, C of S equal to 1 by Ts, that is equal to what? G of S. So this is G of S divided by 1 plus 1 by Ts, also G of S into 1. Next you have to reduce this 1 by Ts, then take the LCM here, Ts plus 1 divided by Ts. Both the Ts are get cancelled. Finally we get the answer 1 by Ts plus 1. So what is the transfer function of the first order system? C of S by R of S equal to 1 by Ts plus 1. We are going to analyze the system response to inputs such as unit step, unit ramp and unit impulse function. First of all, unit step response of the first order system. Already I have explained what is the mathematical representation of the unit step signal. R of t is 1 when t is greater than or equal to 0, 0 when t is less than 0. R of t equal to 1, so R of s equal to 1 by s. Already we got the transfer function of the standard first order system. C of s by R of s equal to 1 by Ts plus 1. Here C of s is the output and R of s is the input. Here I am going to apply the R of s equal to unit step input. So C of s equal to 1 by Ts plus 1. Here put the value of R of s, that is 1 by s. Okay, now the equation becomes 1 divided by s into Ts plus 1. So this is the output C of s. And next I am going to find out the C of t value. What is the output response? For this, first of all I am going to apply the partial fraction of the equation. So first write 1 by s into Ts plus 1. How to separate this? A by s plus b by Ts plus 1. Then multiply s into Ts plus 1 on both sides of the equation. Okay, here if you multiply s into Ts plus 1, both are get cancelled. And here if you multiply s into Ts plus 1, so s and s get cancelled. Here if you multiply s into Ts plus 1, Ts plus 1, Ts plus 1 get cancelled. And we get 1 is equal to A into Ts plus 1 plus Bs. First of all, I am going to find out the constant A and B. To find out the constant A, have to put the value s is equal to 0. If I put the value s is equal to 0, the second term vanishes and the first term A into t into 0 plus 1. So A is equal to 1. And next, equate the coefficient of s. So how to equate this? See here, what is the coefficient of s? A, t is the coefficient. So how to write A into t? What is the coefficient of s? That is b. So A into t plus b equal to 0. And already we got the answer for A. So put A is equal to 1. So b is equal to minus t. Next we have to apply these values directly in the partial fraction. So C of S is 1 by S minus 1 by Ts plus 1. And next I am going to find out C of t by taking inverse Laplace transformation. So L inverse of C of S here equal to L inverse of 1 by S minus L inverse of t divided by Ts plus 1. Because this is not 1 and this value equal to t. Okay, next, what is 1 by S? What is the Laplace transformation of 1 by S? That is equal to 1. And how to find out this Laplace transformation of t divided by? Have to take t outside. So S plus 1 by t. So t get cancelled. What is the Laplace transformation of 1 by S plus 1 by t? That is equal to e power minus t by t. So 1 minus e power minus t by t. So this is the answer for the response due to unit step input. Okay. So 1 minus e power minus t by t. Next I am going to draw the graph using these values. First of all, take t in the x-axis and c of t in y-axis. First of all, I am going to put t is equal to 0. So if I put t is equal to 0, so this term 1 minus 1 e power 0 1. So the first starting that value is 0. And afterwards I have to put the values 1 by 1. I'll get this curve. So the last value 1 minus e power minus t is equal to, for example, t is equal to infinity. So 1 minus 1 by e power infinity. So 1 by 1 by infinity. So 1 minus 0. So the value equal to 1. So 1 it will be a constant value. It will reach as the value in 1 in the final time, that is t is equal to infinity. So this is the graphical representation of the output response of the first order system due to standard step signal. And next we are going to see unit ramp response of the first order system. First of all, what is the unit ramp input? R of t is equal to t when t greater than or equal to 0, 0 when t is less than 0. So R of t is equal to t. Apply Laplace transformation of the equation 1. Already I have explained n factorial divided by s power n plus 1. So R of s equal to 1 by s square. And next I am going to write the transfer function of the first order system. C of s by R of s is 1 by ts plus 1. C of s equal to R of s divided by ts plus 1. Put the value of R of s, that is 1 by s square into ts plus 1. Apply the partial fraction. So 1 by s square into ts plus 1. How we can separate this? A by ts plus 1 first, then b by s plus c by s square. Then what is the next step? Multiply s square into ts plus 1 on both LHS and RHS of the equation. So the value obtained is 1. Here ts plus 1 and this ts plus 1 get cancelled. The remaining term is s square. So a into s square plus b into 1s is cancelled. So b into s into ts plus 1 plus c into s square and s square get cancelled, ts plus 1. Next I am going to put the value s is equal to 0. So if we put s is equal to 0, we will get the answer c is equal to 1. Then equate the coefficient of s. Here is there any coefficient of s? No. And here bs into ts, that is bs ts, bs square into t. So this is the coefficient of s square. And the next term plus bs, the coefficient of s is b. And here the coefficient of s is c into t. Have to apply the value c is equal to 1. So b is equal to minus t. And then equating the coefficient of s square. A plus b into t. That is equal to 0. Put the value here. A is equal to minus t into b. So already we are having the minus t. Minus t is multiplied with this minus t, will get plus t square. Then I am going to apply ABC values in the equation. So C of s is equal to t square by ts plus 1 minus t by s plus 1 by s square. Then I am going to take the inverse Laplace transformation in order to obtain the value C of t. So for this t square, I am going to take t outside. So t I am going to take outside, so s plus 1 by t. For the second term, no problem, and third also no problem. So this t is cancelled with this t square. So finally we get the answer. What is the Laplace inverse of t divided by s plus 1 by t? That is t into e power minus t by t minus what is the Laplace transformation of 1 by s? That is 1 plus what is the Laplace transformation of 1 by s square? That is t. So this is the final expression for C of t. Okay, see, this is the final expression. After getting this expression, you have to separate t, and this capital T or the time response is common for both the terms, term number 2 and term number 3. So you have to take t outside. So 1 minus e power minus t by t. So this is the ramp response, that is C of t. And next we are going to see unit impulse response of the first order system. Already I have explained what is the Laplace transformation of del of t, that is equal to 1 when t is equal to 0, and that is equal to 0 when t is not equal to 0. So the Laplace transform of this del of t equal to r of s equal to 1. Okay, now I am going to write the transfer function C of s by r of s is 1 by ts plus 1. Okay, C of s is equal to 1 by ts plus 1 because r of s is equal to 1. So C of s is 1 by, have to take t outside, t into s plus 1 by t. How to write the inverse Laplace transformation for this? So L inverse of 1 by t into s plus 1 by t is 1 by t into e power minus t by t. Next we are going to see the graphical representation. See, first put t is equal to 0. What about the value of C of t? That is 1 by t. Okay, if we increase the value of t further, finally we get the answer 0 because e power minus infinity. So 1 by e power infinity or 1 by infinity is 0. So the final answer may be 0. So these are the various responses of the first order system. And next we are going to see the standard second order system. So next we are going to see the time response of the second order system. Let us consider the second order system shown in figure. As I have already told, the second order means the power of s, that is highest power of s in the denominator polynomial. So s into s square. So this is the second order system. Here what is omega n? Natural frequency of oscillation. Undamped natural frequency. And what is delta? Is a damping ratio. Normally the book zeta is given. So zeta, here I have used delta here. Delta also a damping ratio. Next I am going to find out the closed loop transfer function of this given block diagram. As I have already told, in a block diagram reduction, how to reduce the negative feedback loop, that is g of s divided by 1 plus g of s into h of s. Here h of s is equal to 1, that is the unity feedback system, and g of s is given omega n square divided by s into s plus 2 delta or 2 zeta omega n s. Using this, I am going to find out the transfer function. So C of s by r of s is equal to, have to put the g of s first, so omega n square divided by s into s plus 2 zeta or delta omega n, the whole divided by 1 plus omega n square divided by s into s plus 2 delta omega n. Next, take the LCM on the denominator term. So s into s plus 2 delta omega n plus omega n square, the whole divided by s into s plus 2 delta omega n. So both the values are get cancelled. Finally, we get the answer C of s by r of s equal to omega n square divided by s into s plus 2 delta omega n plus omega n square. And what is C of s by r of s? So this is the standard transfer function of the second order system. So omega n square divided by s square plus 2 delta omega ns plus omega n square. This equation is very much important in the competitive examination and the other examinations. Okay, next I am going to explain unit step response of the second order system. Okay, first unit step input mathematically represented as r of t is 1 when t is greater than or equal to 0, 0 when t is less than 0. Then I am going to explain how to take the Laplace transformation. Already I have explained. So r of s equal to 1 by s. And next the same equation once again you have to write C of s divided by r of s equal to omega n square divided by s square plus 2 delta omega ns plus omega n square. Next put the value of r of s. So C of s is equal to omega n square divided by s, 1 by s. So instead of r of s put 1 by s. So s into s square plus 2 delta omega ns plus omega n square. And next what's the next step? To find out C of t. So how to find out C of t? To apply the partial fraction technique. Then only we can separate the variables. So omega n square divided by s square into s into s square plus 2 delta omega ns plus omega n square, that is equal to a by s plus bs plus c divided by s square plus 2 delta omega ns plus omega n square. So both RHS and LHS are multiplied by s into s square plus 2 delta omega ns plus omega n square. See here the s and s get cancelled and we are having s square plus 2 delta omega ns plus omega n square along with a. And for the second part bs plus c into s only, because this s square plus 2 delta omega ns plus omega n square get cancelled. Now I am going to put s is equal to 0. So s is equal to 0, I can easily find out the value of a. So because a only having the constant term. So remaining the first term, second term get cancelled and a into omega n square, both are get cancelled. Here s is equal to 0, these are get cancelled. So a into omega n square equal to omega n square, so a is equal to 1. Then equate the coefficient of s squared. See a plus b into s b equal to, is there any s square term? No. So that is equal to 0. So put a is equal to 1. So b is equal to what? B is equal to minus 1. And next I am going to explain how to find out the value of c. So to equate the coefficient of s, to find out the value of c, that is 2 delta omega n into a plus c. So c is equal to what? Minus 2 delta omega n. Okay, next substitute the values of a, b and c in the equation 3. So c of s equal to what? 1 by s, because a is equal to 1, bs plus c. So b is equal to what? B is equal to minus 1, so minus s. C is equal to also minus 2 delta omega n, the whole divided by s square plus 2 delta omega ns plus omega n square. So C of s equal to 1 by s minus, take minus the common. So I have next I am going to separate the numerator term s plus 2 delta omega n as s plus delta omega n plus delta omega n. Here minus is there, put minus, divided by s square plus 2 delta omega ns plus omega n square. And next 1 by s plus delta omega n. Here the numerator s plus delta omega n is there. In the similar manner, I can change the denominator term also. So how to change like s plus delta omega n something? So for this, I am going to take the equation s square plus 2 delta omega ns plus omega n square. Take the center term, divide it with 2. Divide it with 2 and add the square of this and subtract the square of this. So add means delta square omega n square minus delta square omega n square. In similar manner, you have to do like this. Delta omega n divided by s square plus 2 delta omega ns plus omega n square plus delta square omega n square minus delta square omega n square. Okay, next C of s equal to 1 by s plus delta omega n. How we can write this? S square plus 2 delta omega n plus delta omega n the whole square. Okay, this is look like a plus b the whole square, no? So s plus delta omega n the whole square plus I have to take omega n square minus delta square into omega n square. Take omega n square common. So inside I am having 1 minus delta square. Here also minus delta omega n divided by s plus delta omega n the whole square plus omega n square into 1 minus delta square. What is omega n into? Omega n into 1 minus delta square. So that is equal to omega d square. So omega d square is omega n square into 1 minus delta square. Here damn natural frequency of oscillation. What is here omega n? And damn natural frequency of oscillation. So wherever omega n square into 1 minus delta square is there, instead of this you have to put omega d square. So next I am directly apply the formula here, because cos omega t is equal to s by s square plus omega square. What is sin omega t? Sin omega t is equal to omega divided by s square plus omega square. In the similar manner, 1, what is the Laplace transformation of 1 by s? 1 minus, here for example, e power minus at into cos omega t. How we can represent this? First write s plus a divided by s plus a the whole square plus omega square. We can write like this. In the similar manner, so what is the value of s plus delta omega n divided by s plus delta omega n the whole square plus omega d square? First write e power minus delta omega n t into cos omega dt. Already have given the formula. And C minus delta omega n. Here I am going to write this formula that should be equal to the sine formula. So sine formula is what? Omega divided by s plus a the whole square plus omega square. But instead of omega, here this is the omega d square. So instead of this omega, we are having omega d. So I have to multiply and divide by omega d. So omega d and multiply with omega d. So delta omega n into 1 by omega d into e power minus delta omega n t into sine omega dt. Okay, in the next 1 minus e power minus delta omega n t is a common for both the terms. So how to write this? Cos omega dt plus delta omega n divided by omega n into 1 minus delta square. So what is the value of omega d? Omega d square equal to omega n square into 1 minus delta square. From this, what is omega d? Omega d is equal to omega n square root of 1 minus delta square. So I have to substitute the value here. So finally I get C of t is equal to 1 minus e power minus delta omega n t into cos omega dt plus delta omega n divided by omega n into 1 minus delta square into sin omega dt. So from this, what is the here take the LCM. So root of 1 minus delta square into cos omega dt plus delta into sin omega dt. What is cos theta damping ratio? Zeta or delta. So zeta is equal to cos theta. And what is sin theta? Square root of 1 minus delta square. So sin theta is square root of 1 minus delta square. Here instead of 1 minus delta square, put sin theta. And for this, you have to put, instead of delta, you have to put cos theta. Okay, sin theta into cos omega dt plus cos theta into sin omega dt. So this is look like sin A cos B plus cos A sin B, no? So how to write the formula? Sin A plus B. So sin A plus B is equal to sin A cos B plus cos A sin B. So C of t is equal to 1 minus e power minus delta omega n into t divided by square root of 1 minus delta square into cos omega dt into sin theta plus sin cos theta into sin omega dt. So you have to apply the formula here. Sin A plus B equal to sin A cos B plus cos A sin B. So here also C of t equal to 1 minus e power minus delta omega n into t divided by 1 minus delta square into sin omega dt plus theta, because instead of A we are having omega dt, instead of B that is theta. So after finishing this, I am going to draw the C of t response. So this is a graph shows C of t with respect to time. So first put t is equal to 0. So if you put t is equal to 0, so e power 0, that value into, so 1 minus e power 0. Okay, almost e power 0 equal to 1. So if you multiply this with 0, so sin 0, sin theta and this, that is root of 1 minus delta square, here also root of 1 minus delta square. So listen, first I have to put t is equal to 0. So in this equation, C of t equal to 1 minus e power minus delta omega n t, that is 0, divided by square root of 1 minus delta square into, what is sin omega dt? T is equal to 0, no? So sin of 0 plus theta, that is sin theta. What is the value of sin theta? That is square root of 1 minus delta square. Both get cancelled. 1 minus 1 equal to 0. So the curve is starting from 0. And what is the last point of the curve? C of t equal to, put t is equal to infinity. So 1 minus e power minus infinity. So infinity is multiplied with any term, will get the minus infinity. So 1 minus 1 by e power infinity, the value equal to 1. So finally it will reach some oscillation, it will reach as a final steady state value, that is 1. So this is the response of the step response of the second order system. Next, I am going to explain about the damping ratio. So, what is damping ratio? Damping ratio is the ratio of the actual damping to the critical damping. So, damping ratio delta equal to actual damping divided by critical damping. Okay, next I am going to explain the characteristic equation. So what is characteristic equation? The denominator polynomial of the closed loop transfer function is known as characteristic equation. The characteristic equation of the second order system is given by a square plus 2 delta omega ns plus omega n square equal to 0. Already we have seen the transfer function of the standard second order system. In a standard second order system, the denominator equation is a square plus 2 delta omega ns plus omega n square equal to 0. And next I am going to find out the roots of the characteristic equation. Okay, so how to find out the root? Here you have to use the formula minus b plus or minus square root of b square minus 4ac divided by 2a. Here this is a is equal to 1. So b is equal to what? B is equal to 2 delta omega n. What is c? C is equal to omega n square. Okay, I am going to apply the formula minus b plus or minus square root of b square minus 4ac by 2a. So what is b here? Minus 2 delta omega n plus or minus, what is b square? B square is 2 delta omega n the whole square, then minus 4ac, 4 into a into omega n square. Okay, divided by 2a, 2 into 1. Okay, next I am going to get two roots here. One of the root is minus delta omega n plus or minus 2 get cancelled by this 2. Minus delta omega n plus or minus omega n square root of delta square minus 1. How I can rewrite this equation using the complex number? S1 in comma S2 equal to minus delta omega n. Have to take minus 1, square root of minus 1 outside. So how I can take the minus 1 outside? See here, from this equation, minus delta omega n plus or minus omega n square root of delta square minus 1. So minus delta omega n plus or minus omega n, have to take minus 1. So 1 minus delta square. So if we take this minus 1, omega n plus or minus omega n square root of minus 1 into square root of 1 minus delta square. What is the value of square root of minus 1? That is the imaginary value, that is j. So minus delta omega n plus or minus iota, that is j omega n into square root of 1 minus delta square. So using the roots of this characteristic equation, I can find out the different types of system. There is undamped system, underdamped, overdamped and critical damped. First of all, case number 1. In a case number 1, undamped system. Undamped means there is no oscillation. That is known as undamped system. Delta equal to 0. Okay, here I have to put delta equal to 0. The damp vanishes. And here we are having j plus or minus j omega n only. So the roots are plus or minus j omega n. The roots are purely imaginary. The system is undamped and oscillating. Next I am going to explain the second case, that is a critically damped system. For the critically damped system, put delta equal to 1. So what is our equation? S1 comma S2, that is equal to delta omega n plus or minus j omega n minus delta omega n square root of 1 minus delta square. Okay, here I have to put the value delta equal to 1. So this term vanishes and we'll get the answer S1 comma S2 equal to minus omega n. Next I am going to explain the overdamped system, that is delta is greater than 1. So but what about the root s1 comma s2 equal to minus delta omega n. So delta omega n plus or minus j omega n square root of 1 minus delta square. Okay, here delta is greater than 1. If delta is greater than 1, so what will be the value? The value should be negative. So 1 minus some negative. So negative means negative in a negative. So j into j, negative 1 square root of minus 1, and this square root of minus 1 will get the minus 1 value. That is the real number. So minus delta omega n plus or minus omega n square root of del square minus 1. And the last case is underdamped system. Underdamped system, the delta value is less than 1. So if we substitute delta value equal to less than 1. Less than 1 means here we get the complex number only. So what about the roots? The roots of the characteristic equations are s1 comma s2 is minus delta omega n plus or minus j omega n into square root of 1 minus delta square. So s1 comma s2 equal to minus delta omega n plus or minus j omega d. That's all. These are about the different types of system with respect to a different damping coefficient, different values of damping coefficient. Next, we are going to see the problems. So obtain the unit step response of the unity feedback system whose open loop transfer function is g of s is 4 divided by s into s plus 5. Here g of s is given, so an open loop transfer function, and h of s that is equal to 1 because unity feedback system. So here how to find out the closed loop transfer function? C of s by r of s equal to g of s divided by 1 plus g of s into h of s. H of s is given, that is equal to 1. G of s is also given 4 divided by s into s plus 5. Now I am going to substitute the value here. C of s by r of s is 4 by s into s plus 5, the whole divided by 1 plus 4 divided by s into s plus 5. So from this, I am going to take the LCM in the denominator. So 4 divided by s into s plus 5, the whole divided by s into s plus 5 plus 4, the whole divided by again s into s plus 5. So numerator s into s plus 5 is there. Denominator also we are having s into s plus 5. Both s into s plus 5 get cancelled. And finally I am going to reduce the term. C of s by r of s is 4 by s square plus 5s plus 4. And next here the problem given is apply the unit step input. So unit step input, what is r of t? R of t is 1, r of s is 1 by s. What is C of s by r of s? 4 by s square plus 5s plus 4. So C of s equal to r of s into 4 by s square plus 5s plus 4 instead of r of s plus put 1 by s. So C of s is 4 divided by s square plus 5s plus 4 into 1 by s. Okay, and next how to find out C of t? Already we have seen the previous derivations. How we can find out the value C of t by applying the partial fraction. So partial fraction, to separate the variables, then only we can apply the partial fraction. So 4 divided by s into s square plus 5s plus 4, that is equal to a by s plus b by s4 plus c by s plus 1. Both LHS and RHS are multiplied with s into s plus 4 into s plus 1. So here full terms, denominator term get cancelled, and here s only cancel, remaining 2 terms are available. And s plus 4 only cancel, s into s plus 1 is there. And s plus 1 only cancel, we are having s into s plus 4. Okay, now I am going to apply the values here to find out variable that is constant a, b and c. So a is equal to, s is equal to 0. So 4 into a equal to 4. Here this term get vanishes. This term also get vanishes. So 4 equal to 4a, a is equal to 1. and put s is equal to minus 4. If you put s is equal to minus 4, the first term disappear and third term also not there. We are having the second term only. So b into minus 4 into 4 minus 4, minus 4 plus 1, that is minus 3. So b into 12 equal to 4, or b is equal to 1 by 3. In a similar manner, equating the coefficient of a square. Here we are having the coefficient a, here the coefficient b, and here the coefficient c. But in the left hand side of the equation, there is no coefficient of a square, simply put 0. So 1 plus 1 by 3 plus c is equal to 0, c is equal to minus 4 by 3. After finishing this, have to substitute the value of a, b, c in the equation a. So c of s is 1 by s plus 1 by 3 into s plus 4 minus 4 by 3 into s plus 1. Taking inverse Laplace transformation, what is the inverse Laplace transformation of 1 by s? That is equal to 1. What is the inverse Laplace transformation of 1 by s plus 4? That is similar to 1 by s plus a e power minus at. So 1 plus e power minus 4t by 3 minus 4 by 3 into e power minus t. That's all. This is the problem 1. Next, I am going to explain the problem 2. For the closed loop transfer function, C of s by r of s is 3 into s plus 2 divided by s plus 4 into s plus 1 the whole square of a control system. Find the step response to a unit step input. First, you have to write C of s by r of s directly here because the transfer function is given directly. But we have to apply r of s in this transfer function. So C of s equal to r of s into 3 into s plus 2 divided by s plus 4 into s plus 1 the whole square. Okay, put the value of r of s, that is 1 by s. Now we have to apply the partial fraction in order to separate the variables. So a by s plus 4 plus b by s plus c by s plus 1 and plus d by s plus 1 the whole square. If square term is there, we have to separate like this. So both LHS and RHS, we have to multiply by s into s plus 4 into s plus 1 the whole square. So on the left hand side of the equation, we are having 3 into s plus 2 and right hand side a into s plus 4 and s plus 4 get cancelled, s into s plus 1 the whole square plus b into this s and s get cancelled. So we are having s plus 1 the whole square into s plus 4 and plus c into the s plus 1 and s plus 1, one of the s plus 1 get cancelled. We are having c into s plus 1 into s plus 4 and the last one d into s plus 1 the whole square is cancelled. We are having s into s plus 4. First put s is equal to 0 and the term disappears, vanishes, and this term also here b term is there, c term get vanishes and d term. The separate s term all get vanishes because s is equal to 0. So b into 1 into 4 divided, that is equal to 3 into 2, that is 6. So b is equal to what? 6 divided by 4, that is 3 by 2. And next put s is equal to 1. So if s is equal to minus 1. Minus 1 means the first term get vanishes and second term, third term also. For fourth term only there. So minus 1 into 3, that is equal to 3 into 2 minus 1, that is 3 into 1. So 3 into 1 is d into minus 1 into 3. So d is equal to minus 1. Then put s is equal to minus 4, we get the value a. Equate the coefficient of s cube, we get the value a plus b plus c is equal to 0. 1 by 6 plus 3 by 2 plus c, that is equal to 5 by 3. That is minus 5 by 3. So after finishing this, I have to substitute these values in the partial fraction only. C of s is 1 by 6 into s plus 4 plus 3 divided by 2 into s plus 5 by 3 into s plus 1 minus 1 by s plus 1 the whole square. Okay, inverse Laplace transformation of C of s obtained is 1 by 6 into e power minus 4t plus 3 by 2 minus 5 by 3 into e power minus t e power minus t, because 1 by s plus 1 the whole square, how we can write is, first s plus 1 the whole square, we have to write this as t. So t into 1 by s plus 1 the whole square. So first of all we have to write t, and if you put the value t, then remaining term is e power minus at. At means e power minus t. So t into e power minus t. Next I am going to explain the next topic, that is the steady state error. So what is steady state error? The error between the actual output and the desired output at the time tends to infinity. See, this is the actual output. Actual output that is multiplied with the feedback element, and desired output, actual input and the desired output. So actual input is R of S, desired output is B of S. Because C of S is multiplied with H of S, we will get a B of S value. So this is the that is error. R of S is the Laplace transformation of applied input. C of S is the Laplace transformation of the output. E of S is the Laplace transformation of error signal. H of S is the Laplace transformation of feedback signal. B of S is the Laplace transformation of measurement signal. So how to write E of S from this equation? R of S minus B of S, that is equal to E of S. From this, what is B of S? B of S is C of S into H of S, that gives the value B of S. So instead of this B of S, put C of S into H of S. So R of S into C of S into H of S. What is C of S? C of S is E of S into G of S. So put the value E of S into G of S. So in this equation, E of S is equal to R of S minus E of S into G of S into H of S. So take E of S and you have to E of S is there. Here also we are having E of S, G of S and H of S. So from this I can rewrite the equation like this: E of S plus E of S into G of S into H of S is R of S. From this I have to take E of S outside. So inside I am having 1 plus G of S into H of S, that is equal to R of S. From this equation, what is E of S? That is R of S divided by 1 plus G of S into H of S. So for a unity feedback system, H of S is equal to 1. So put H of S is equal to 1. E of S is R of S divided by 1 plus G of S. What is the steady state error? Limit t tends to infinity, E of t. Otherwise, we can write like this: limit S tends to 0, S into G of S. So Es is equal to limit S tends to 0, S into, put the value of E of S, R of S divided by 1 plus G of S into H of S. And next I am going to explain the steady state error due to unit step input. For a unit step input, R of S is equal to 1. So what is the steady state error? Already we have seen the steady state error equation: limit S tends to 0, S into R of S divided by 1 plus G of S into H of S. Here I have to put the value R of S here, that is 1 by S. S and S get cancelled and we will get the value limit S tends to 0, and for the second one, limit S tends to 0. In this way we can separate this. So Kp equal to limit S tends to 0, 1 divided by 1 plus G of S into H of S. What is Kp here? Kp is the positional error constant. Kp is positional error constant. The positional error constant Kp is not this answer. The Kp equal to limit S tends to 0, G of S into H of S. This is the positional error constant. From this, Es is equal to 1 by 1 plus Kp. Okay, next I am going to explain the type 0 system. So how to write the general transfer function k into S plus Z1 into S plus Z2 divided by S plus P1 into S plus P2. For a standard system, the denominator having poles and numerator having zeros, we have to write like this. So what is Kp? Kp is the positional constant. Limit S tends to 0, G of S into H of S, K into S plus Z1 into S plus Z2 divided by S plus P1 into S plus P2. Put the value here, we get Z1 Z2 by P1 plus P1 P2, that is the constant value. So Es is equal to 1 by 1 plus Kp. And next I am going to explain the type 1 system. For a type 1 system, how we can find out the value? For a type 1, the Kp equal to limit S tends to 0, G of S into H of S. Okay, here I have to put the type 1 system. Type 1 means the separate power of s in the denominator polynomial. If we put s is equal to 0, what about the value of s also 0? So 0 in the some value, that is equal to 0. So what about k divided by 0? The k divided by 0, that is equal to infinity. So kp equal to infinity for this case. And what is the ESS? Steady state error is 1 by 1 plus kp, no? So 1 by 1 plus infinity, 1 by infinity, that is equal to 0. So what about ESS? ESS equal to 0 here. And next, I am going to explain the steady state error due to unit ramp input. This is general formula for the steady state error. Limit s tends to 0, s into r of s divided by 1 plus d of s into h of s. For a unity ramp input, r of t is equal to t. So r of s is equal to 1 by s square. You directly have to apply the value. So how I can write this? kb is equal to, no, first write ESS equal to what? ESS equal to limit s tends to 0. R of s is what? 1 by s square, no? 1 by s square divided by 1 plus g of s into h of s. Okay, from this, limit s tends to 0, 1 divided by 1 by s square so 1 divided by, not 1 by s square plus s square into g of s into h of s. So next, how to write limit s tends to 0. Next write 1 by limit s tends to 0. What about the first term? First term should be 0. Second term, limit s tends to 0. S, here this is s square, no? So s, already we are having one s. So s and s cancel. There is no s square, s only. So s into g of s into h of s. So this limit s tends to 0, s into g of s into h of s, that is equal to velocity error constant, limit s tends to 0, s into g of s into h of s. So here general for the general transfer function is derived. So kv equal to k into z1 z2 p1 p2 is a constant. Okay, next, how to find out ESS? ESS equal to what? 1 by 0 plus kV. So 1 by kV is the answer for the ramp input. Here for a type 2 system, how we can represent this? G of s into h of s equal to k into s plus z1, s plus z2 divided by s square into s plus p1 into s plus p2. So kv is equal to limit s tends to 0, s into g of s into h of s. Directly have to put the value g of s into h of s. S's get cancelled and we'll get the value 1 by 0 because denominator we are having separate s. If you put the value 0, so the complete term that is equal to 0. So 1 by 0 equal to infinity. So ESS equal to 1 by kV or 1 by infinity equal to 0. So this is the unit ramp input. So next I am going to explain the unit parabolic input. For a unit parabolic input, first of all I am going to write the standard steady state error at ESS is limit s tends to 0, s into r of s divided by 1 plus d of s into h of s. So limit s tends to 0, s into 1 by s cube. Okay, this is the Laplace transformation of the parabolic signal, 1 by s cube, 1 plus d of s into h of s. So see here, s into s cube cancel. So limit s tends to 0, 1 by s square plus s square into g of s into h of s. Okay, if you put s is equal to 0, the first term get cancelled and the second term you have to apply the limit. Limit s tends to 0, s square into g of s into h of s. Okay, this value equal to Ka. K is the acceleration error constant. Okay, and what is ESS? ESS is 1 by Ka. And next we have to apply the type 0 system. For a type 0 system, s into 1 by s square divided by 1 plus gs into h of s. Okay. Here I am going to explain the type 1 system. G of s into h of s is k into s plus z1 into s plus z2 into s plus z3 divided by s into s plus p1, s plus p2 into s plus p3. Okay, k is equal to what? Limit s tends to 0, s square into g of s into h of s. Here I have to apply the value and s's get cancelled and the value equal to 0, k equal to 0. So what is ESS? 1 by 0. 1 by 0 is what? That is infinity. And next we are going to see the type 2 system. For a type 2 system, g of s into h of s is k into s plus z1, s plus z2, s plus z3 divided by s square because type is 2. S square into s plus p1 into s plus p2 into s plus p3. Here k is equal to what? Limit s tends to 0, s square into g of s into h of s. Have to put the value s square and s square get cancelled and we'll get the answer constant. So ES is equal to 1 by Ka, also constant. So from this I conclude this positional error constant for the step input is Kp equal to limit s tends to 0 g of s into h of s. Velocity error constant, velocity or ramp input Kv equal to limit s tends to 0 s into g of s into h of s. And acceleration error constant for the parabolic input Ka equal to limit s tends to 0 s square into g of s into h of s. So this is a tabular column I have given. First type of system Kp, Kv and Ka. And step input what is the error value, velocity what is the error value, and for a parabolic what is the error value. So parabolic the error equal to 1 by Ka. Okay, see here we have to remember like this. First 0, 1, 2, 3 in this way have to write, and Kp, Kv, Ka in this way have to write. First write Kp and Kv term we have to write Kv in the that is diagonal only have to write Ka. Okay, remaining Kp after Kp put 0, 0 and before Kv put infinity, after Kv 0 and before Ka put infinity. And next how to remember this? Here ESS is 1 by 1 plus Kp and 1 by Kv 1 by Ka. And after 1 by 1 plus Kp the value is infinity, infinity. The reason is 1 by 0. In this way have to remember. So 1 by the inverse of the value 0, infinity, infinity. Here also the inverse of 0, infinity, and the inverse of infinity the value is 0. So you have to remember like this. And infinity the value is 0 and 0 and 1 by K. Okay, that's all. These are about the standard error for the second order or any type of any order system, and different error constant like Kp, Kv as well as K. Next, the last topic, that is the time domain specification. It's the important one in the second order transfer function. And first of all, I am going to explain the important definitions of the time domain specification. First, delay time. What is delay time? The delay time is the time required for the response to reach 50% of the final value in the first attempt. And next, rise time. The rise time is the time required for the response to rise from 10 to 90% and 5 to 95% and 0 to 100% of the final value. So there are different systems available. Already we have discussed the underdamped system 0 to 100%, overdamped 10 to 90%, and critically damped, that is then the overdamped and underdamped only. Okay, next, peak time. The peak time, that is the time required for the response to reach the first peak overshoot, because we are having the different peaks available. Here this is the peak number 1, that is first peak. Here overshoot, and this is the undershoot, the second undershoot, third peak, that is overshoot, and fourth undershoot. So this is the response of the second order system subjected to unit step input. Okay, next, maximum peak overshoot. How to find out the maximum peak overshoot? Peak overshoot is defined as the normalized difference between the time response peak and the steady state output. C of Tp minus C of infinity divided by C of infinity. into 100. Or C of Tp minus 1 also we can write for the maximum or peak overshoot. See here, this is the value 1 C of T response. This one is known as maximum overshoot. So what is the time? The corresponding overshoot time is Tp, peak time. So how to write this? C of Tp. So what is this? Is C of Tp minus C of T is 1 now, minus 1. So difference between C of Tp and 1, that is also a maximum or peak overshoot. Next, I am going to explain the settling time. Settling time is the time required for the response to reach and stay within the specified tolerance or specified limit, usually 2% or 5% of its final value. Steady state error. Already have explained. The steady state error is defined as the error between actual output and the desired output. Actual input, not actual output. Actual input and the desired output at the time t tends to infinity. Next, I am going to explain the derivation of time domain specification. So before we see the time domain specification, so this is the response of the standard second order system. Here this is the delay time required for the response to reach 50% of the final value, and rise time taken for the response to reach 100% of the final value, and time taken for the response to reach peak overshoot. And the time, and that's the difference between C of Tp minus 1, that's the maximum overshoot. What is settling time? It is allowable tolerance span. Settling time, it is stay within the response, stay within the specified limit, that is 2% or 5% tolerance. Okay, first derivation is the delay time. This is also an important derivation. Okay, in a delay time, the time required to reach 50% of the final value at the very first time. For deriving the delay time, have to take C of T. C of T is the equation already we have got from the second order system. 1 minus e power minus delta omega n into t divided by square root of 1 minus delta square into sine omega dt plus theta. Here what is sine theta? Square root of 1 minus delta square. Cos theta is the damping ratio. From this, what is tan theta? Square root of 1 minus delta square, that is sin theta divided by cos theta. So theta equal to tan inverse square root of 1 minus delta square divided by delta. So C of t is, once again I am going to repeat the equation, 1 minus e of e power minus delta omega n into t divided by square root of 1 minus delta square into, what is the value already I am having, that is omega dt plus theta. So sine of omega dt plus theta. Theta have to substitute the value here. Okay. So sine of omega dt plus tan inverse square root of 1 minus delta square divided by delta. So this is the value of theta. For delay time, put C of t equal to 1 by 2 at t is equal to td. Okay, half 1 minus e power minus delta omega n into td divided by square root of 1 minus delta square omega sine of omega d td plus tan inverse 1 minus delta square divided by delta. So after the number of calculations, we get the final answer as td. td is 1 plus 0.7 delta divided by omega n. This is the answer for delay time. Next, I am going to explain the rise time derivation. For underdamped system, the time required to reach 0 to 100% of the final value. C of t, once again write 1 minus e power minus delta omega n into t divided by square root of 1 minus delta square into sine omega dt plus tan inverse square root of 1 minus delta square divided by delta. For underdamped system, t is equal to what? Tr at rise time. C of t equal to 1. The response of the system is 1. Okay, or 100%. 1 equal to 1 minus e power minus delta omega n into tr divided by 1 minus delta square sine omega dtr plus tan inverse square root of 1 minus delta square divided by delta. So from this, 1 minus 1 equal to 0, e power minus delta omega n into tr divided by square root of 1 minus delta square. Sine into equal to 0. Here, two terms are there. One is exponential term and another one is sine term. Exponential term not equal to 0. Anyway, like e power 0, it is equal to 1. And e power minus infinity only, the value equal to 0. So, remaining all the values, it is not equal to 0. So, next this term only equal to 0. Sine of omega dtr plus tan inverse square root of 1 minus delta square divided by delta equal to 0. What is sine inverse of 0? Here, what are the values? Sine value equal to 0. That is n pi. N pi is pi, 2 pi, 3 pi and so on. So, omega dtr plus tan inverse square root of 1 minus delta square by delta equal to sine pi. So, both sines are get cancelled and pi only. So, from this, what is TR? TR is pi minus tan inverse square root of 1 minus delta square divided by delta, the whole divided by omega d. So, what is the final answer? TR is pi minus theta by omega d. That is the rise time derivation. And next I am going to explain the derivation of the peak time. So, peak time is the time required to reach the maximum peak value at a very first attempt. In this derivation also, we have to take C of t is 1 minus e power minus delta omega n into t divided by 1 minus delta square sine omega dt plus tan inverse square root of 1 minus delta square by delta. To obtain peak time by differentiating C of t with respect to time. So, dc of t divided by dt is 1. What is the differentiation? 0. Here I have to apply the uv formula. So, u into dv. So, what is the differentiation of uv? So, u dv plus v du. So, first you have to differentiate the term, this term, and keep it vu, and next you have to differentiate the second term and keep the first term. Okay, delta omega into t divided by square root of 1 minus delta square into e power minus delta omega into t. Here already one minus is there, both the minus are get cancelled. Sine omega dt plus tan inverse 1 minus delta square by delta. Okay, next minus, here this value no change, e power minus delta omega into t divided by square root of 1 minus delta square. Then you have to differentiate this term, sine of this. So, that is cos of this. Okay, the nan into what is the value? Differentiation of this is omega n into square root of 1 minus delta square. Okay, from this we can find out sine of omega d tp plus theta minus omega d cos omega d tp plus theta. Okay, and from this e power minus omega t, you have to take it outside, that is not equal to 0, and only one term, sine term, will be equal to 0. So, how to represent this sine term? That is delta omega n into sine omega d tp plus theta omega n into square root of 1 minus delta square cos omega d tp plus theta equal to 0. So, already one term that is missing, that is delta omega n. Okay, delta omega n. There is no t here. Delta omega n. Here e power minus delta omega n into tp that mentions the peak time. Okay, this is the equation. Okay, here delta omega n sine and omega d, how to write this? Omega n square root of 1 minus delta square. In this way, so e power term that will not equal to 0. So, only one term that is equal to 0, that is delta omega n sine omega d tp plus theta minus omega d, that is omega n square root of 1 minus delta square into cos omega d tp plus theta equal to 0. So, if we equate this equal to, both omega n get cancelled, and from this and tan omega d tp plus theta equal to 1 minus delta square root of 1 minus delta square divided by delta. So, that is equal to what? Tan theta. So, from this tan theta is equal to tan n pi plus theta. We can write like this, no? Tan n pi plus theta. So, next How we can equate this? Omega dTp plus theta equal to tan n pi plus theta. Tan can get cancelled. Omega dTp plus theta equal to n pi plus theta. So from this equation, Tp is equal to n pi divided by omega n square root of 1 minus delta square. So this is the derivation of peak time. And next, derivation of maximum overshoot. So maximum or peak overshoot MP is C of Tp minus 1. MP equal to the same equation, once again you have to write 1 minus e power minus delta omega into Tp divided by square root of 1 minus delta square into sine omega d Tp plus theta minus 1. At t is equal to Tp minus 1, we will get a maximum overshoot. So pi minus omega d. Already we got the answer, that is pi by omega d. So you have to substitute the value pi by omega d here. So 1 and this 1 get cancelled and we'll get e power minus delta omega n divided into Tp divided by square root of 1 minus delta square sine pi plus theta. What is 180 sine 180 plus theta? Sine 180 plus theta, that is equal to sine theta only minus sine theta. So that minus and already one minus is there. Both are get cancelled. So MP equal to what? E power minus delta omega n into Tp divided by 1 minus delta square into sine theta. So maximum overshoot percentage of MP equal to, so this is the formula, C of Tp minus C of infinity divided by C of infinity into 100. Let's take the same equation, e power minus delta omega into Tp. No, Tp is what? Pi divided by omega d or omega n square root of 1 minus delta square. The omega square, omega n and this omega n get cancelled. And sine theta is there. What is sine theta? Square root of 1 minus delta square. Both are get cancelled. Finally we get the answer. Percentage of MP is e power minus delta pi divided by square root of 1 minus delta square into 100. And finally we are going to see the settling time. What is settling time? The time required for the response to reach the specified tolerance band 2 and 5%. So for the tolerance band, e power, the second term, you have to take the exponential term because exponential term is a decreasing term. Sine term is not decreasing, exponential only decreasing. So you have to take the exponential term. So e power minus delta omega n Ts divided by square root of 1 minus delta square. So that is 2%. First two different tolerance values are there. One is 2% and another one is 5%. First of all, I am going to apply the 2% tolerance. So 0.02. So e power minus delta omega n into Ts equal to 0.02. By taking natural log on the both sides of the equation, we'll get natural log e is cancelled minus delta omega n into Ts equal to ln 0.02. So that is equal to minus 4. So T is equal to what? 4 divided by delta omega n or 4T. So that is the settling time for the 2% tolerance. And next, T is equal to 1 by delta omega n, that is equal to a time constant. So we can write like this, T is equal to 4T. For a 5% of the tolerance band. Here also the same thing we have to apply. Minus delta omega n into T is equal to ln 0.05, that is equal to minus 3. And from this, T is equal to 3 by delta omega n, that is equal to 3T. Okay, here I have to take the response of the second order system. Here I can explain the tolerance. See, this is the second order system. Here C of t is equal to 1. Okay, 1. And first, this is the tolerance value, tolerance band. In this way, the tolerance value should be reduced further and further. For example, I am going to take this a 3t. 3t means 95%, 5% tolerance. 95% it will reach the steady state. And here next, almost it will be reduced, 98%. Something reduced and there is no error at all. So 98% means 2%. So if you increase the time constant 40, we will get a 2% tolerance, the 5% tolerance. 2t means the tolerance value is more. Okay, that's all. These are about the settling time. Okay, next I am going to explain the problem. The open loop transfer function g of s equal to 25 into s plus 5 has a unity feedback. Time domain specification, we have to find out the time domain specification: delay time, rise time, peak overshoot, settling time, and output response. So closed loop transfer function we are going to find out. Already open loop transfer function is given. G of s is 25 divided by s into s plus 5, but unity feedback system and unit step signal is applied. H of s is equal to 1. Have to apply this formula. G of s is 25 into s plus 5 divided by 1 plus 25 into s plus 5. And I have to cross multiply this 25 by s plus 5 into plus 25. From this I have to expand this denominator s square plus 5s plus 25. So this is the second order system. Here I am going to apply the step input. Okay. Here directly we have to find out, comparing with the second order system, C of s by R of s, omega n square divided by s square plus 2 delta omega n s into omega n square. Okay, from this, what is omega n? Omega n square is 25. Compare both the equation, 25. Omega n is plus or minus 5. Then next 2 delta omega n is 5. Okay, so from this, what is delta? Delta is 5 divided by 2 into omega n, that is delta equal to 0.5. So next I am going to find out the damped natural frequency of oscillation. What is omega d? Omega n into square root of 1 minus delta square. So 5 into square root of 1 minus 0.5 the whole square. So what is omega d? 4.33 radians per second. Okay, that is omega d. And afterwards I have to find out theta. Theta is the damping ratio. How to find out? Tan inverse square root of 1 minus delta square divided by delta. So both the values I have to substitute, I will get the answer 1.047. Then delay time, directly we are having the formula 1 plus 0.7 delta divided by omega n. Directly have to substitute these values and find out that is delay time 0.27 seconds. And rise time somewhat more than the delay time, that is correct. Pi minus theta by omega d, so 0.4834 seconds. And then peak time also somewhat larger than the rise time pi by omega t, that is also correct. Then peak overshoot, that is e power minus delta pi divided by square root of 1 minus delta square, so peak overshoot is 16.31%. And what is the settling time for 2% tolerance? That is TS is 1.6 seconds. And for 5% tolerance, TS equal to 1.2 seconds. Okay. And it will reach the 5% tolerance, and next 1.6 second, that is 2% tolerance. Output response C of t is, had put all the value 1 by e power minus delta omega n into t square root of 1 minus delta square into sin omega dt plus theta. Here you have to put the value for delta omega n, and here you have to put the value for omega d and theta. Then you get the final output response. Thank you. Have a nice day. Up to this, the time response is completed. In the next video, I'll explain the next topic, that is the root locus and the root stability criteria. Thank you. Thank you for watching this video.